This is CPE 233 Experiment 1L Introduction. So Experiment 1L has to do with a GCD module, which is greatest common divisor. Essentially what it has is two ROMs, and each of those ROMs has 16 values in it. And what this program is going to do is look at those 16 values two at a time, one from each ROM, determine the greatest common divisor, and write those values to RAM. Once it goes through all 16 values, it's going to iterate through the RAM to find the largest value, which is essentially the value with the largest magnitude, and then it's going to display that large value and stop at that point. So there's four parts to this program. One is the starting state. So in the starting state, it's going to be displaying the largest value. So when you fire this up, the largest value is going to be 0 because all memory fires up to be cleared when you power on the FPGA. So the next step is you're going to find the greatest common divisors of the pairs of ROM data. When you're doing that, you switch to the two-digit display mode. There's two-digit values in this mode, and what you'll be doing is displaying the ROM values under consideration. Each of the values is 99 or less, which is kind of handy because then it fits on the display. So once you go through all the ROM data, what you're going to do, what you have done is you've saved the largest values, the greatest common divisors, to RAM. You're going to iterate through that RAM, and while you're doing that, you're going to display the RAM contents. And once you iterate through that entire RAM, what you've essentially found your largest value, you're going to go back to state 1 and display that large value. So constraints on this is I want you to use only digital modules, standard digital modules, no magic circuits. And I've provided most of these modules for you. I mean, not most of them, all of them. And most of the modules that I've provided, except for the FSM and the GCD modules, have instantiation templates in the file headers. You got to use these. I don't want you changing these files. You got to know how to instantiate these things without changing the file, changing the data width in the instantiation, not changing the file. You got to do it. If you don't do this, I'll kick it out and ask you to redo it. So I don't want any fancy mathematical operators anywhere except in the RCA and counters. And as for the FSM, which is going to be controlling this project, I give you a starting template on Canvas. Use that one, and that's really the only module that I provide that does not have an instantiation template because it's expected to change. So no more than 8 states, probably 5 states is more appropriate, but don't just keep the number of states down. The FSM should be 100% dependent upon the width of the data in this sense. I don't want any data inputs into the FSM. The FSM should not know how much data is in the RAMs and the ROMs. Only memory in your FSM should be the state variables. Don't put anything else in there. Don't input non-status data to the FSM as well. And then there are a few other details. Check the experiment for those details. Okay, and most importantly, most of these resources are provided on Canvas. Instantiate them. Do not change those modules. What you have to do is when you instantiate them, you can override the parameters. All these models except the FSM is parameterized. Use it. If you don't do that, I'll ask you to resubmit it. Okay, lots of standard stuff out there. Go ahead and use it all. Like I said, the FSM template does not have an instantiation template in it because it's expected to change. And you've got to use the provided 7-segment display module. You don't want to write your own on this one. So basic design approach is you understand the problem, You select the modules for your circuit, just plop them down there. Then you connect them, and essentially what you're doing is connecting the data, control, and status lines. And once that's all connected, you design FSM. The FSM is going to control the circuit, and once I have that designed, I'm going to translate that FSM into a Verilog model. And at that point, I should be done. For this problem, you should understand the problem, of course, and design it on paper. Keep it super simple. Don't be clever in any way. That's going to cause problems. And if you're not sure what to do, this is a great experiment to take in stages. Essentially, there's 3 stages in it. Take them one at a time. So once you get it designed in paper, you're going to model it in Verilog, and then you're going to test your design. You can test it on the board, or most likely you're going to have to use the simulator. Okay, and the issue is if you ask me questions about anything, I need to see circuit diagram and a state diagram. Or if you email me, send me some schematics of the circuit and a state diagram. This is the top level module. It's waiting for a button press, and once it does that, that's all it is. It's going to display all the numbers as you need to. So it's a very simple top level interface. This is the greatest common divisor module. It has a couple inputs here. Of course, it's clocked. These are the 2 data inputs that it's going to take to find the greatest common divisor of, and this is just simply a signal that says, hey, the inputs are stable, go find the answer. So the answer is going to end up here, 32-bit value, and also it's going to send out a status signal saying, hey, I'm done. So what's going to happen here is you got a valid answer there, and then you're going to hit this go signal. So once you hit that go signal here, it is going to start the process, and namely it's going to turn the done signal off. At that point, the output data, this data here, is no longer valid. It's going to take a while to get valid data, and when the data is valid, meaning the GCD is done, it's going to turn on that done signal. And that's how you know it's done, and essentially that's going to allow you to transfer to a new state and do something new and fun. So this is due midnight on this, let's see, 6th day of class. Probably should be the 7th day of class. And yeah, it should be the 7th day of class. I got to adjust that. I'll adjust that on Canvas. You should start this early so that you can ask questions. If you get stuck on something, starting it the day before is what a lot of people do, and it gets very busy, and I won't have time to answer everyone's question. So this is not a simple experiment, but it will prepare you for the remainder of the course. So if you haven't worked with a simulator, haven't worked with state machines, haven't worked with other God knows what other devices from your 133 course, now's your chance to learn this stuff.